Picture a world shrouded in ice, where massive fountains of crystalline water erupt into space, creating a cosmic spectacle unlike anything else in our solar system. This isn't a scene from science fiction. This is Enceladus, one of Saturn's most captivating moons, and today we're going to delve deep into its mysteries. In the vast expanse of our cosmic neighborhood, few celestial bodies have captured the imagination of scientists and space enthusiasts quite like this icy satellite. As we speak, enormous geysers are blasting water into space from a hidden ocean beneath its frozen surface, creating a breathtaking display that has revolutionized our understanding of where life might exist in our solar system. Have you ever gazed at the night sky and wondered if we're truly alone in the universe? The story of Enceladus challenges everything we once thought we knew about the potential for life beyond Earth. This small, ice-covered moon, despite its modest size, has become one of the most promising candidates in our search for extraterrestrial life. Its active geology and hidden waters present us with tantalizing possibilities that would have seemed impossible just a few decades ago. The discovery of Enceladus's remarkable features has opened up a new chapter in our exploration of the solar system. Here is a world that, despite temperatures cold enough to shatter rubber like glass, harbors a warm, dynamic ocean beneath its icy crust. This isn't just any ocean. It's one that we know contains many of the basic ingredients necessary for life as we know it. The fact that this water is actively being ejected into space through surface fissures gives us a unique opportunity to study its composition without even having to drill through the ice. As we journey together through the mysteries of Enceladus, we'll explore how this tiny moon, barely 500 kilometers in diameter, has managed to maintain such remarkable geological activity. We'll discover why scientists believe its subsurface ocean might harbor the conditions necessary for life, and what future missions might reveal about this fascinating world. Welcome to Exploring the Universe, where we unravel the cosmos's greatest mysteries together. Today's journey into the secrets of Enceladus promises to challenge your imagination and expand your understanding of what's possible in our solar system. Whether you're a seasoned space enthusiast or just beginning to explore the wonders of astronomy, the story of this remarkable moon is sure to captivate you. If you share our passion for unlocking the mysteries of space, make sure to subscribe to our channel and turn on notifications. Together, we'll continue to explore the incredible secrets our universe holds, one celestial body at a time. Now, let's dive into the fascinating world of Enceladus and discover why this small, icy moon has become one of the most intriguing objects in our cosmic neighborhood. Let's begin our closer look at this remarkable moon by understanding its basic characteristics. Enceladus is truly a cosmic miniature, measuring just 500 kilometers in diameter. To put this in perspective, if Earth were the size of a basketball, Enceladus would be smaller than a cherry. Despite its diminutive size, this moon has become one of the most fascinating objects in our solar system. One of the most striking features of Enceladus is its brilliant white surface. This celestial body holds the distinction of being the most reflective object in our entire solar system, with an astonishing ability to reflect 99% of all sunlight that reaches it. To appreciate just how remarkable this is, imagine standing on Enceladus's surface at noon. Despite being 10 times farther from the sun than Earth, the surface would still be blindingly bright due to this extraordinary reflectivity. This makes Enceladus shine like a perfect diamond in Saturn's orbit, creating a spectacular view through even moderate telescopes. This exceptional reflectivity comes from its surface composition, a pristine coating of fresh, clean water ice that is constantly replenished by its active geological processes. Unlike many other icy bodies in the outer solar system that have become darkened by cosmic radiation and debris over billions of years, Enceladus maintains its pristine appearance through continuous resurfacing. Think of Enceladus as nature's perfect snowball floating in space. However, this isn't your ordinary snowball. It's more like a cosmic geode. From the outside, it appears as a serene, frozen world. But beneath this peaceful exterior lies a surprisingly active and dynamic interior. Imagine a city-sized snowball, but one with a warm, churning heart at its center. This contrast between its frigid exterior and dynamic interior makes Enceladus truly unique in our solar system. The moon appears like a perfectly polished pearl suspended in the vast cosmic ocean, its bright surface standing out dramatically against the darkness of space. This isn't just poetic imagery. The moon's perfect spherical shape and bright white surface really do resemble a magnificent pearl orbiting Saturn. The comparison becomes even more apt when we consider that, like a pearl, Enceladus's beautiful exterior holds clues to complex processes happening within. What makes this celestial pearl even more remarkable is its location within Saturn's complex system. Enceladus orbits within the E-ring, Saturn's outermost ring, and as we'll discover later, this small moon actually plays a crucial role in creating and maintaining this ring through its geological activity. This interaction between moon and ring system creates a cosmic dance that has captivated astronomers since its discovery. Despite its small size and seemingly simple appearance, Enceladus challenges our understanding of planetary geology. Here is a world that should be too small and too far from the Sun to maintain any significant geological activity, yet it remains one of the most geologically active bodies in our solar system. This apparent paradox has led to fascinating discoveries about how small celestial bodies can maintain internal heat and activity, revolutionizing our understanding of planetary science. The story of Enceladus reminds us that in space exploration, size isn't everything. This relatively tiny moon, barely the width of some countries on Earth, has managed to become one of the most intriguing objects in our solar system, proving that sometimes the most remarkable discoveries come in the smallest packages. Perhaps the most remarkable features on Enceladus are what scientists call the tiger stripes, four massive parallel fissures carved into the moon's south polar region. These aren't ordinary cracks. Each is about 130 kilometers long, 2 kilometers wide, and 500 meters deep. Named after cities from ancient Baghdad, Alexandria, Baghdad, Cairo, and Damascus, these fissures are the source of one of the most dramatic displays of geological activity we've ever observed beyond Earth. The Cassini spacecraft, during its historic mission to Saturn, made a series of breathtaking discoveries about these features. It identified more than 100 active geysers erupting from these tiger stripes, creating spectacular plumes that shoot high into space. But what makes these geysers truly extraordinary is the sheer power behind them. The water, ice particles, and vapor are blasted out at speeds exceeding 400 meters per second. That's nearly 900 miles per hour, faster than a commercial jet airplane. The scale of this activity is mind-boggling. Every single second, these geysers collectively eject more than 200 kilograms of water into space. To put this into perspective, imagine standing at the foot of Old Faithful in Yellowstone National Park. Now multiply that spectacle by 100, and imagine it happening in the frigid vacuum of space. The amount of water being expelled would fill an Olympic-sized swimming pool in just a few hours. The force behind these eruptions is truly astronomical. If you were to try to replicate this level of water output using ordinary garden hoses, you would need over 1 million of them operating at full blast simultaneously. Even more remarkably, some of this ejected material reaches such high velocities that it escapes Enceladus's gravity entirely, contributing to Saturn's E-ring and creating a thin atmosphere around the moon. These aren't just simple eruptions. They're complex systems that vary in intensity over time. Scientists have observed that the geysers' activity changes as Enceladus orbits Saturn, suggesting that tidal forces play a crucial role in driving these spectacular displays. During certain parts of its orbit, the fissures are squeezed by Saturn's gravitational pull, forcing more material out through the vents. The temperature readings from these tiger stripes have also surprised scientists. While the surrounding ice sits at a frigid 200 degrees C, the areas around the fissures are remarkably warmer, with temperatures reaching 80 degrees C. This significant temperature difference provides clear evidence of heat flowing from Enceladus's interior, suggesting complex geological processes at work beneath the icy surface. What makes these geysers even more fascinating is their composition. The Cassini spacecraft's instruments detected not just water ice and vapor, but also organic compounds, salts, and silica particles in the plumes. These materials tell us something remarkable. They suggest the presence of hydrothermal activity on the seafloor of Enceladus's subsurface ocean, similar to the deep-sea vents we find in Earth's oceans. The discovery of these geysers has revolutionized our understanding of planetary geology. Here was a tiny moon, far from the sun's warmth, displaying levels of activity that rival or exceed many larger bodies in our solar system. It's a reminder that the solar system still holds many surprises, waiting to be discovered. One of the most incredible aspects of these geysers is that they provide us with a unique opportunity. They're essentially delivering samples of Enceladus's subsurface ocean directly into space, where we can study them without having to drill through the ice. It's as if the moon itself is helping us explore its secrets. Tell us in the comments, which aspect of Enceladus's remarkable geysers surprised you the most? Is it their incredible speed, their massive volume, or perhaps the fascinating tiger stripes from which they emerge? The confirmation of a global ocean beneath Enceladus's surface marked a watershed moment in our exploration of the solar system. This discovery came through careful analysis of the moon's slight wobble as it orbits Saturn, a subtle movement that could only be explained by the presence of a liquid layer separating the moon's rocky core from its icy shell. Think of it as a cosmic version of a raw egg, where you can feel the liquid sloshing inside when you gently shake it. The scale of this hidden ocean is astonishing. Scientists estimate it reaches depths of approximately 30 kilometers, deeper than Earth's deepest ocean point, the Challenger Deep in the Mariana Trench. When you consider Enceladus's small size, this ocean becomes even more impressive. It holds a proportionally larger volume of water than Earth's oceans relative to the moon's size. The ocean exists under an ice shell that varies in thickness from about 5 kilometers at the South Pole to possibly 30 kilometers at the equator. What makes this ocean particularly intriguing is its ability to maintain liquid water despite Enceladus's distance from the sun. The moon essentially functions as a cosmic pressure cooker. The immense pressure from the ice sheet above, combined with heat generated by tidal forces from Saturn's gravitational pull, creates conditions where water can remain liquid even in the cold outer solar system. The temperature and pressure conditions are remarkably similar to those found in Earth's deep-sea hydrothermal vents. Perhaps the most exciting aspect of this ocean is what's in it. Analysis of the material ejected through the geysers has revealed a complex chemical soup. Scientists have detected organic compounds, including various carbon-containing molecules, methane, and even complex macromolecular organics. The presence of silica particles suggests active hydrothermal activity on the ocean floor, where hot water interacts with rocks, just like in Earth's oceans. The chemistry of this ocean is further enriched by its interaction with the moon's rocky core. Evidence suggests that chemical reactions between the water and rocks create conditions similar to Earth's alkaline hydrothermal vents, environments that some scientists think might have played a crucial role in the origin of life on our planet. The ocean's salinity, comparable to Earth's oceans, adds another intriguing parallel to our home world. The pressure dynamics within this ocean are fascinating. As Saturn's gravitational forces squeeze and stretch Enceladus, they create tidal heating that not only helps keep the water liquid, but also drives circulation within the ocean. This movement helps distribute nutrients and heat, creating a potentially dynamic ecosystem much like Earth's ocean currents. What's particularly remarkable is how this ocean communicates with space. Through the tiger stripes at the South Pole, it's as if Enceladus has created natural sampling ports for scientists. The water from the deep ocean travels up through cracks in the ice, flash freezing as it erupts into space, preserving the chemical signatures of what lies beneath. It's nature's way of providing us with a direct sample of this alien ocean without requiring us to drill through the ice. The discovery of this ocean has profound implications for our understanding of where liquid water can exist in the solar system. Before Enceladus, we assumed bodies needed to be within a certain distance from the Sun to maintain liquid water. This small moon showed us that internal heat sources, combined with the right pressure conditions, can maintain liquid water even in the outer solar system. Like a cosmic pressure cooker, Enceladus's ocean system is a testament to the dynamic and surprising nature of our solar system. Here, billions of miles from the Sun, we find an ocean that not only exists, but actively shapes its host world, creating conditions that tantalizingly mirror some of the most extreme but life-supporting environments on Earth. This subsurface ocean represents one of the most promising environments for potential extraterrestrial life in our solar system, challenging our assumptions about where life might exist and reminding us that the universe may be far more hospitable to life than we once thought. When we consider the basic requirements for life as we know it, Enceladus checks an impressive number of boxes. Scientists generally agree that life needs liquid water, organic compounds, energy sources, and stable conditions maintained over geological timescales. Remarkably, Enceladus appears to possess all these fundamental ingredients. The comparison with Earth's extreme environments is particularly compelling. Deep beneath our oceans, around hydrothermal vents where superheated water rich in minerals bursts from the seafloor, we find thriving ecosystems that don't depend on sunlight. These environments bear striking similarities to what we believe exists on Enceladus's ocean floor. The alkaline hydrothermal vents found on Earth, such as the Lost City in the Atlantic Ocean, host complex microbial communities that derive energy from chemical reactions between water and rock, exactly the type of chemistry we're detecting on Enceladus. The possibility of microbial life on Enceladus is more than just speculation. The chemical signatures detected in its plumes suggest the presence of methanogenic conditions, environments where certain types of microorganisms on Earth thrive by producing methane as a metabolic byproduct. The detection of molecular hydrogen in Enceladus's plumes is particularly exciting, as it's a potential food source for microorganisms similar to those found in Earth's deep-sea hydrothermal systems. The ocean's chemistry appears to be quite favorable for life. Its slightly alkaline pH, similar to that of Earth's oceans, along with the presence of carbon dioxide, organic molecules, and nitrogen-containing compounds, provides many of the chemical building blocks necessary for biological processes. The continuous circulation driven by tidal heating helps distribute these nutrients, creating a potentially dynamic ecosystem. Looking to the future, several missions are being proposed to explore Enceladus in greater detail. One of the most exciting concepts is the Enceladus Life Finder, which would fly through the moon's plumes multiple times, analyzing their composition with instruments far more sensitive than those aboard Cassini. Another proposal, the Enceladus Life Signatures and Habitability mission, would focus specifically on searching for biomarkers, chemical signatures that could indicate the presence of life. These future missions could employ various sophisticated techniques to search for signs of life. Mass spectrometers could analyze the molecular composition of ice grains in the plumes, looking for patterns that might indicate biological processes. Cameras could capture high-resolution images of the tiger stripes and their surrounding terrain, helping us understand the geological processes that maintain this potentially habitable environment. Perhaps most intriguingly, we wouldn't need to land on Enceladus or drill through its ice to search for life. The Moon is essentially delivering samples directly to us through its plumes. This makes Enceladus uniquely accessible among potentially habitable worlds in our solar system. A spacecraft could simply fly through these plumes, collecting and analyzing material that comes directly from the subsurface ocean. The implications of finding even microscopic life on Enceladus would be profound. It would suggest that life can arise in places we once thought impossibly hostile, dramatically expanding our understanding of life's potential in the universe. If we found life that used different biochemical processes from those on Earth, it would suggest that life can develop in multiple ways. Conversely, if we found life similar to Earth's, it would raise fascinating questions about potential connections between the two worlds. The search for life on Enceladus also helps us develop and refine techniques for detecting biosignatures, signs of life, that could be applied to the exploration of other potentially habitable worlds in our solar system and beyond. As we develop more sophisticated tools and methods for detecting life in Enceladus's ocean, we're simultaneously advancing our ability to search for life throughout the universe. Whether or not we ultimately find life on Enceladus, studying this remarkable moon has already revolutionized our understanding of where life might exist in the universe. It has shown us that habitable environments can exist far from the sun's warmth, maintained by other sources of energy, and that even small worlds can harbor oceans with conditions potentially suitable for life. The discovery that Enceladus actively contributes to Saturn's E-ring represents one of the most remarkable findings in planetary science. This revelation fundamentally changed our understanding of planetary ring systems and demonstrated how dynamic and interconnected the various components of Saturn's system truly are. Saturn's E-ring is unique among the planet's rings. Unlike the main rings, which are dense and well-defined, the E-ring is diffuse, extending from about 3 to 8 Saturn radii from the planet. What makes this ring particularly special is that it's made primarily of microscopic particles of water ice. And here's where the connection to Enceladus becomes fascinating. Through careful observations and data analysis from the Cassini mission, scientists discovered that these ice particles originate from Enceladus's geysers. When the water vapor and ice crystals blast out from the tiger stripes at speeds exceeding 400 meters per second, some of this material achieves escape velocity. Rather than falling back to the moon's surface, these particles are launched into space, where they begin orbiting Saturn, forming and continuously replenishing the E-ring. The process is nothing short of poetic. Enceladus, orbiting within the E-ring, acts like a cosmic fountain, constantly spraying material that creates a vast, shimmering halo around Saturn. It's as if the moon is painting its own orbit with tiny ice crystals, creating a celestial ring that spans hundreds of thousands of kilometers. What's particularly fascinating is the fate of these particles. As they orbit Saturn, they slowly spread out both inward and outward from Enceladus's orbit, creating the diffuse nature of the E-ring. Some particles eventually spiral inward due to various forces, including Saturn's gravity and radiation pressure from the Sun, while others drift outward, extending the ring's reach. This continuous process of ejection and dispersion makes the E-ring a dynamic structure, constantly being renewed by Enceladus's activity. The discovery of this connection helps explain several mysteries about Saturn's E-ring that had puzzled scientists for years. For instance, it explains why the ring appears brightest near Enceladus's orbit and why it's composed primarily of fresh, clean ice crystals, rather than the darker, more weathered material found in Saturn's other rings. The constant supply of fresh material from Enceladus keeps the E-ring bright and pristine. This relationship between moon and ring also provides a spectacular example of how seemingly small objects can have far-reaching effects in space. Here is a moon, barely 500 kilometers in diameter, creating and maintaining a ring system that spans hundreds of thousands of kilometers. It's a powerful reminder that in space, size isn't always the determining factor in an object's importance or influence. The Enceladus E-ring connection represents a perfect climax to our exploration of this fascinating moon, as it ties together all the elements we've discussed: the powerful geysers, the subsurface ocean, and the moon's remarkable geological activity into a single, magnificent phenomenon that literally shapes its surroundings on a planetary scale. It shows us how the intimate processes occurring within this small moon connect to one of the most visible and spectacular features of the Saturn system, creating a cosmic display that continues to captivate both scientists and space enthusiasts alike. This discovery stands as a testament to the interconnected nature of planetary systems and reminds us that some of the most spectacular phenomena in our solar system can come from the most unexpected sources. It's a fitting climax to the story of Enceladus, demonstrating how this small but dynamic moon continues to surprise and amaze us with its outsized influence on its cosmic neighborhood. Our exploration of Enceladus stands as a powerful reminder that the most extraordinary discoveries often come in unexpected packages. This small moon, barely visible as a pinpoint of light from Earth, has completely transformed our understanding of where we might find the ingredients for life in our solar system. Its story teaches us a profound lesson about the dangers of underestimating any object in our cosmic neighborhood, no matter its size. What makes Enceladus particularly special is how it challenges our preconceptions. Before the Cassini mission, few would have predicted that such a small, distant world could maintain liquid water, let alone host complex geological processes. Yet here, we find a world with active geysers, a global subsurface ocean, and chemistry that tantalizingly hints at the possibility of life. It's a humbling reminder that our universe is far more complex and surprising than we often assume. The implications of Enceladus's discoveries extend far beyond this single moon. If such a small world can maintain conditions potentially suitable for life, how many other, seemingly insignificant celestial bodies might harbor similar secrets? This question has profound implications for our search for life beyond Earth and our understanding of how common habitable environments might be in the universe. Enceladus also demonstrates the incredible value of persistent, detailed exploration. Each close pass by Cassini revealed new mysteries and insights, building a picture of a world far more dynamic and complex than anyone had imagined. It reminds us that in space exploration, as in science generally, our most significant discoveries often come from patient, methodical investigation, rather than single dramatic moments. Looking forward, Enceladus stands as a prime target for future exploration. Its active geysers provide a unique opportunity to sample a subsurface ocean without having to drill through miles of ice, making it one of the most accessible, potentially habitable environments in our solar system. The questions it raises about the possibility of life beyond Earth make it a compelling destination for future missions. As we conclude our journey through the wonders of this remarkable moon, we're left with a profound appreciation for the complexity and potential of our cosmic neighborhood. Enceladus shows us that the universe holds infinite possibilities, waiting to be discovered by those curious enough to look closely and patient enough to study carefully. If today's exploration of Enceladus has sparked your curiosity about the wonders of our solar system, we invite you to share this journey with others who share your passion for scientific discovery. Don't forget to like this video and subscribe to Exploring the Universe, your gateway to the cosmos's most fascinating mysteries. Remember, in the vast expanse of space, even the smallest bodies can hold the biggest surprises. Enceladus stands as a testament to this truth, reminding us that in science, as in life, we should never judge the importance of something merely by its size. The greatest mysteries often hide in the most unexpected places, waiting for curious minds to unlock their secrets. Join us next week as we continue our exploration of the universe's most fascinating phenomena. Until then, keep looking up and wondering, for in those moments of wonder, we connect most deeply with the infinite mysteries of our cosmic home.